This is video 4.4.1, and the goal, we'll be looking at trigonometric functions of any angle, no matter what the situation. So we're going to be seeing our third definition, so you'll want to make sure you have your definition sheet handy so you can add to your sheet for the last time. So we're given this example. Let P equal the point -3, -5 be on a terminal side of theta. Find each of the six trig functions of theta. So first let's take a look at the picture of what this would be. Since P is -3, -5, and it's on the terminal side of theta, that means it's going to land, theta is this nice large angle that's going to land in quadrant 3, because that's where -3, -5 would land. Now, in order to use one of my definitions that I already have, I need to notice first that this is not a unit circle. Okay, and also that this is a rather large angle. It's larger than 180 degrees, so my right triangle trig definitions will also not work. This triangle, this reference triangle, this blue triangle here is called a reference triangle, will help me, and I know the side lengths are 3 and 5, okay, but this particular triangle would not be on a unit circle because the radius would have to be greater than 1, and the unit circle is defined as only being a circle that has a radius of 1, and that point P would not be on that circle. So this tells me I need a different definition of the trig functions. So we are going to define one more definition of the trig functions that will work for any angle in any situation. You already have the following definitions, that sine is y, cosine is x, and tangent is the ratio between y and x. So now we need another definition for when we don't have a unit circle. So the final definition is for any circle, if we have this theta that has a terminal side that goes through point P, P is x comma y, sine will be defined as the ratio between y and r. So notice it's still y, but now it's y over r, where r is the radius of a circle that would go through P, or it's the distance from 0, 0 to xy. So it's that distance from this origin to the point. Now this definition also has a similar twist. Okay, by the way, so r is that blue line right there. The definition for cosine is similar to that of sine in that it's going to be x over r. It's because it's x over the radius. So it's still sort of adjacent over hypotenuse, but r is used for the hypotenuse because it's the radius of that circle that would go through P. And the third definition, tangent actually doesn't change because tangent is not dependent on how big the circle is. It's a ratio between the two sides. So tangent will still be the ratio between y and x for any point P on the circle, on any circle. So now, notice the similarities. We're keeping a consistent values, x's and y's, but the one thing that we need to know is how to find the radius, r, and r squared will always equal x squared plus y squared. It's a twist on the Pythagorean theorem. So we're going to use this formula to find r to solve these problems. So in order to find r, we're going to use this Pythagorean theorem. You'll see it in the next example, so it should make more sense when you start to see it in the next example. So let's take a look at that example. So we're going back to what we started with. We're still thinking about our picture with our triangle. Sine will be y over r. So if I look at my picture, I see y is -5, but I don't know what my r value is. I know my r value is that hypotenuse of the triangle, but I'm not sure what the r value is in this case. So r, we're going to use the formula, r squared equals y squared, x squared plus y squared. Hopefully that should make sense because of this picture. It's a right triangle, we can use Pythagorean theorem. And it doesn't matter that I use -3 or +3, because when you square it, you get the same exact value. So solving this out, I'll get r squared equals 9 plus 25, which is 34. And of course, I have to take the square root of both sides, so I get r equals square root of 34. So now I can find the sine value. The sine value is y over r, so it'll be -5 over square root of 34. Now, of course, we have to make it proper, so we'll get -5 squared root of 34 over 34. So I'm going to do something similar for cosine, but now cosine is x over r, and so I'm going to do -3 over square root of 34, but of course I have to make it proper. So I'm going to times top and bottom by square root of 34 to get my answer for cosine. Tangent is a lot simpler. It does not use the radius, so it's just y over x, -5 over -3. That simplifies to positive 5/3. Now we'll look at our other functions. Cosecant. Cosecant of theta is the reciprocal of sine, but I'm going to use one of my previous values for sine, negative 5 over square root of 34, because I know that that value will become proper if I flip it upside down. That's the value of cosecant of theta. If I use the other value that I originally had for sine, then I would have to do some work in making it proper. So I'm going to use one of the previous values for sine of theta because it'll make my life easier. Secant of theta, I'm going to do something similar, but of course this is the reciprocal of cosine, so I'm going to cosine, I'm going to take that value, I'm going to flip it upside down, and that's my secant value. And last but not least, cotangent, that's the reciprocal of tangent. This one's much easier, it doesn't matter which one I use. 5/3 will become 3/5. So those are your 6 trig values, trig ratios for this particular situation. So now, in order to make our lives easier, if we learn one more thing about the signs of the trigonometric functions, we'll be able to more quickly and efficiently solve some problems. So the signs of the trig functions. This is really asking where are the trig functions positive and where are they negative. We're only going to worry about sine, cosine, and tangent since the other ones are just reciprocals. So for instance, if sine was negative, then of course cosecant would be negative because all we do is flip it upside down. So let's take a look first in this first quadrant. Everything is positive. Everything is positive because, well, x is positive because x is the y value. X is positive because it's in the first quadrant, and cosine is the x value, so cosine's positive. Sine is positive because sine is the y value. Now what about the next quadrant? Remember, sine is the y value. Notice it's positive. Cosine is the x value. X is negative in quadrant 2. So that tells me that my sine value is positive, and my cosine value will be negative in this quadrant. Now, tangent is the ratio between the y and the x, or the slope of the line that goes through the terminal side. And if I were to draw that little line, I would see that it's negative. Or if I divide sine by cosine, positive divided by a negative, I'm of course going to get negative. So tangent is negative in this quadrant. Now how about quadrant 3? Quadrant 3, again, sine is negative because we're in the negative region for y. Y is negative, so sine is negative. Same for cosine. X is negative, so cosine is negative. Now what about tangent? In this case, tangent is positive. Again, it's because of the slope. If I draw that line where that angle would land, it would be a positive slope. Or I could think of it as a negative divided by a negative is a positive. Sine in the next quadrant, quadrant 4, sine will be negative because y is negative. Cosine will be positive because x is positive. Tangent will be the ratio between sine and cosine, negative and positive, so it's going to be negative. And again, I could draw that little sketch, that little line, and see that the slope is negative. So now how are we going to remember this? Now, honestly, you don't have to memorize this, but it's very nice to know because it makes things a lot smoother and quicker in the long run, allows you to solve problems with a little bit more ease and less mistakes. So one quick way to memorize these values is to think about where the things are positive. Quadrant 1, all things are positive, right? So we're going to create a mnemonic device that will help us memorize where what quadrants have positive values. So of course we're going around the circle in a counterclockwise position because that's the way the quadrants are labeled. Quadrant 1, all things are positive. In quadrant 2, sine is positive. So our mnemonic device is going to be all students because in quadrant 1, all things are positive. In quadrant 2, students are positive. S for sine. Sine is positive. S stands for students, N for sine. Quadrant 3, tangent is positive. So we're going to use the letter T. We're going to use the word take. All students take, and last but not least, calculus. Because in quadrant 4, cosine is positive. So if we think about going around the circle, all students take calculus could be a way for us to memorize it. It's a mnemonic device that your book mentions, and I think it's worth mentioning because it's a good device to learn. Maybe you can create your own. But this mnemonic device helps you see where things are positive. In quadrant 1, all things are positive. Quadrant 2, sine is positive. Quadrant 3, tangent. Quadrant 4, cosine. Okay, so this, again, doesn't have to be memorized, but it's a really nice to know. And you can always recreate it by looking at your unit circle and trying to remember where things are and which things are positive and when. So let's take a look at some examples. So how are we going to use this? So let's say tangent is less than 0. We're trying to name the quadrant the angle lies in. The tangent is less than 0 and the cosine is greater than 0. So let's take a look. Let's draw a picture. In this picture, those two shaded areas is where the tangent is negative, right? We just saw that picture in the previous example. So those are the two quadrants where tangent is negative. Now where is cosine positive? Well, quadrant 1 and quadrant 4. So now I can see where theta has to fall because it has to fall where both of those are true. So theta is in quadrant 4. Let's do it again for the second one. Now sine is less than 0. If sine is less than 0, that means y is less than 0, so that's quadrants 3 and 4. If cosine is less than 0, that means x is less than 0. That's quadrants 2 and 3. And I see where they're shaded, it's in quadrant 3. So you don't have to shade, but you definitely have to think about where things are positive, where things are negative. So again, this is going to help us more in the long run with problems like this. Okay, they don't show me a picture, they don't tell me where the angle is, but they tell me the cotangent is negative 4/3 and the sine is greater than 0. So cotangent is negative. So that tells me it has to be in quadrants 2 or 4. Because remember, cotangent is related to tangent. That's the two quadrants where tangent is negative. So I know I'm in quadrant 2 or 4. Now sine is greater than 0. Well, that would be quadrant 1 or 2, because that's when y is bigger than 0. So I can see that this angle would have to be drawn in quadrant 2. Now I can draw a picture of my angle. I can draw a picture of my angle, end of my triangle, because I know cotangent is x over y by definition. So I'm going to label my point xy. xy, that point has to be here because negative 4/3 is my cotangent. So now I'm going to find my sine, cosine, secant, and cosecant. But in order to find sine, I need r. So I'm going to solve for r. I'm going to use the Pythagorean theorem. R squared equals negative 4 squared plus 3 squared. And I end up getting r squared equals 25. Therefore, r is 5. So now I have my r value. With my r value, I can now find sine, cosine, secant, and cosecant. So let's see, sine. Sine is y over r. Y is positive 3 in this case, and r is 5. Sine is done. Cosine. Cosine is x over r. In our case, x is negative 4, and 5 is r. Secant is just the reciprocal of cosine, so I'm simply going to flip that upside down, get negative 5/4. And last but not least, cosecant, reciprocal of sine, so 5/3. So a couple of things. You may have noticed that I tend to put the negative on top. You notice I put the negative on top here. Some students might want to put the negative on the bottom because they flipped this fraction and they would get 5 over negative 4. But know that these, of course, are all equivalent. These two are equivalent. It's just that we typically put the negative on top. That's just the standard way to write it in math. So that's where you'll see me putting it. So definitely bring those questions in if you see some things that I'm doing that doesn't make sense to you. Usually it's because I'm probably using math in a new way that you haven't seen before. So last but not least, here's your checkpoints. Do your best to draw the picture for the multiple choice question and find the cosine of t. For the free response question, it's similar to some of the examples you saw. Figure out what quadrant it will be in if sine is less than 0 and tangent is greater than 0. And be sure to explain how you know. So bring those questions into class. Hopefully you were able to follow this video, and if you have any questions, you've written them down. We'll see you in class.